Hello, beautifuls. This is Atleen, and I'm coming to you with another video. So the information that you see on the screen will be on the CCNA exam, and the topic today is subnetting. The definition of subnetting is dividing a large network into multiple small networks. And we must be able to recall the information on the screen. The addresses are a need to know for the exam. We should be able to look at any IP address and based just on that number, the first octet value, and say that this is a class A, class B, class C, or class E. As you can see, class A is 1 through 126, class B is 128 through 191, and the class C is 192 through 223. And please note, 127 was used for loopback addresses, and class B is used for experimental purposes. So you won't see those on any devices that we will go towards with the exam. So it will only be class A, B, and C. Well, for each class of address, there will be subnet calculations. For each class of address, we have a default subnet mask. Now, default means that we can change. We could change it. We could change it by default. There are 8 subnet bits in each class A, class B, and class C. As you can see on the board, there are 4 sections for the 8 bits per section. 8, 8, 8, and 8. So on the board, we have an example, and the address is 192.168.10.0 and /24. So of course, we're going to put 24 ones into the subnet address, and we're going to have 0 in the host bits because 32 minus 24 is 8. So when we add it all up, we get 255.255.255.0. So as we discussed earlier, default can be changed. So as you can see above, it states 192.168.10.0/25. It was 24 before. So we will discuss how to find the number of network, how to find the number of address on each network, and how to find the number of hosts in each network. Now, to find the number of network, we do start by inputting the ones, as you can see. And as you can see, it states 25. So here we do 2n, which indicates total number of bits borrowed from the host. So it's really simple. All we're doing is borrowing from the host. And we're going to start from the left to the right. So on the left is 2 to the power of 7, and that is 128. So 2 to the power of 1 equals 2, and you can create only 2 networks. How to find the number of IP addresses on each network? 2N here indicates total number of host bits, and that's 2 to the power of 7, which is what I just stated. And that's going to be a minus 2 equals 126. On each network, you will have 128 IP addresses on each network. And how to find the number of hosts in each network. 2N minus 2 here, the N indicates total number of remaining host bits. 2 to the power of 7 minus 2 is 126, and you will have a total of 126 host IP addresses on each network. So you're probably wondering, why do we have to do the minus 2? In every network, the first IP address is reserved for the network ID, and the last IP address is reserved for the broadcast address. So as you can see, like we stated, there's one address reserved for the network ID, which will be 192.168.10.0. And then the broadcast address is reserved as well. That's why we had the minus 2. So 192.168.10.127 is for the broadcast ID. And the in-betweens are the number of IP addresses which can be assigned. So it's going to be 192.168.10.1 through 192.168.10.126. And we will continue from that. It's going to be from 127 to 128. And remember that the first address, IP address, will be reserved for the network ID, and the last address will be reserved for the broadcast ID. So the network ID will be 192.168.10.128, and the in-betweens, number of IP addresses that can be assigned, will be 192.168.10.129 through 192.168.10.254. Okay, well, thank you for listening. Tomorrow, the next video will be on private versus public IP addresses, and I wish you well.